Hello, children. This heights and distances question from grade 10 trigonometry is basically involving the complementary angles. So let us first understand the question. The angles of elevation of the top of a tower. So let's say this is a tower AB and mentioning the height of the tower to be H. So now there are 2 points on the ground. One is 5 meters away. So let's say this is 5 meters away and the other point is 20 meters away. So let's say this point is 20 meters away. So this distance is 5 while this entire distance is 20 meters. But the angle of elevation, so they are in the same straight line, both the points. So the angle of elevation is always that angle which you get when you look up, right? To the top of the tower, let's say if you're looking up from point C. So this will be your angle of elevation. So let's say theta. And when you go to point D, the angle of elevation changes to something which is complementary. So complementary means this angle is 90 minus theta. So now these complementary angles are not in syllabus anymore from last few years. So I'll solve this question from another method. Although complementary angle solution would have been just very quicker, but we will not follow that because as per the new syllabus, complementary angles is not there. So let's try to solve it the other way. So first, if I take triangle ABC, this is theta. If I apply tan theta, so we know that tan theta is perpendicular by base. So tan theta will become h by 5. Or I can say that h is equal to 5 tan theta. This is my step 1. Now, since I don't want to use the complementary angle, so what I'm planning to do, I will use another method. I'll think of the triangle as a whole like this. So let's say this was A, this was B, this was D, and this is 90. If this is 90 minus theta, then naturally this will be theta. Because then only the angle sum property of the triangle is satisfied. 90 plus 90 minus theta plus theta gives 180. So now I'll apply tan theta with respect to in triangle ABD with respect to this vertex A. This theta, right? So then tan theta again, you know, is perpendicular by base. So this opposite side is now acting as the perpendicular BD. And the length of BD is mentioned here as 20. So now I can say that tan theta is equal to 20 by H. This is my second equation. Now, if I substitute the value of this tan theta here, so what I will get? H is equal to 5 tan theta, which means 5 into 20 by H, which means H square is equal to 100, or I can say H is equal to 10 meters. So therefore, the height of the tower is 10 meters here. Thank you so much.